Hello everybody, thanks for coming along today. Can you all hear me all right? Yes. Wave at the back if you can hear me. Excellent, that is good news. Thanks for coming along. I think it's 12 o'clock, so I hope everyone's not like ravenous, because usually like I'm having my lunch around now, so hopefully you can all still concentrate without shaking too much. My name is Selly Neate. I work for IBM. I'm based at the development lab that we've got down in Hursley, which is near Winchester in the south of England. And one of the cool things that we do there is make storage products. So it's all kind of local homegrown stuff that you're going to hear about today in terms of some of the technologies that we've been making at IBM that we hope are going to help you when it comes to making your data, your storage and your infrastructure more resilient against cyber attacks. So what's the role then of storage when we're thinking about ransomware attacks? Because a lot of the story about protecting yourself from ransomware, there's just so many parts of infrastructure these days that are exposed to all of these threats. And there's only a certain amount of it that we can control when it comes to the data and the storage. So if you're thinking about what a typical ransomware attack looks like, there is some kind of threat that is introduced. Maybe someone's credentials have been stolen. I read a cool thing on the BBC, well, not so cool, this morning about being able to use AI to clone people's voices. So just imagine the kind of havoc that could wreak if, there's already cases where you ring up the IT help desk, you pretend to be someone that you're not, you get your password reset, and then suddenly a bad actor is in your network and they're causing all sorts of havocs. And then there might just be unsecure endpoints, attackers that are just literally probing around every IP address that they can get hold of and just trying to sort of like probe about what's weak. So if someone gets into your infrastructure, typically they'll try and look around, see what other systems that they can get access to. And then they'll start connecting with some kind of external server in a process we call command and control, where they're trying to maybe download encryption keys from the dark web, maybe try and download some more malware, get that spread and affected across the whole of the network, and move laterally to try and spread this threat across infrastructure. And frequently, we'll see malware can be lying dormant for months, hundreds of days before someone pulls the trigger and actually starts a destructive attack. What we know is, despite all of these various measures that we've got in place, all of the endpoint protection, all of the security training that we do within our organizations, it isn't quite good enough, because we still get to a point where the ransomware attack is triggered and people's data is compromised. So what I want to talk about today is what happens when the unfortunate and inevitable happens, because I think everyone realizes now ransomware attacks, it's not a case of if, but when, and even how often are these things going to happen. So what's the role when it comes to data? How can you make sure that you're doing the best thing possible to look after your data and the systems where that's stored? Because typically, what are the things that you think about when you've reached this point where your data is compromised and you're starting to think, okay, I think panic is the worst possible thing that can happen. I actually went to a good pitch over at VMware Explore last month, I think it was, or earlier this month actually, isn't it? And a guy said the best thing that you should do if you ever see one of these ransomware threats or one of these alerts triggered is, go and make yourself a cup of coffee. Because the worst possible thing that you can do is panic, overreact, start randomly shutting down systems, and then they might boot up and fire off some more malware. Just stop and think about what it is you're doing. But the truth is that over 50% of people, when they get to this point and they see one of these ransomware alerts, over 50% of organizations will pay the ransom. Why is it that someone pays a ransom? Well, think about it. You've got this countdown here that's saying in however many hours we're going to destroy your data, we're going to sell your data, we're going to leak it in the dark web, unless you take action. So how can you feel confident about not doing that and protecting your business? I think really the answer is, have you got something in place in your organization that makes you feel confident that you can get back up and running again quicker than that countdown? Because if someone says they're going to do something bad in 13 hours, but you're like, oh, that's fine. I've got all these processes in place, which means I know exactly what to do, I know what data to recover, and I know I can get my business up and running again in a couple of hours. You're not going to be tempted to pay the ransom. It starts looking like bad value for money, I would say. So what I want to think about today then is the concept of speed when it comes to making your infrastructure and ransomware resilient. And when we're thinking about data and storage, I think the speed of recovery is critical. And I'm going to talk about two particular things that I think are critical for fast recovery. I would say a lot of these things are not rocket science. They're probably things that you are already implementing within your infrastructure, but I want to think about how all of these things work together. So firstly, maintain a fast and clean recovery point. What do I mean by that? If you want to be able to recover quickly, the quickest possible way you can do that is if you've got your copies of data stored on fast media locally that you're going to be able to click a button and be able to recover from quickly. That's not to say that you shouldn't store copies of your data elsewhere. Obviously, a lot of data backup strategies involve having data stored on different media, in different locations, adds all these extra layers of security. But I would advise, as part of your strategy, don't think that you have to keep it somewhere else. There is still a lot of value in keeping data and backups locally so that you've got that quickest possible restore point. Secondly, immutable snapshots. Anyone here using immutable snapshots today as part of their strategy? I can see nods, and I'm very, very glad about that because we still talk to a lot of customers that don't. And it's not just IBM. Pretty much every storage vendor out there right now, I think even vSAN now has got immutable snapshots. A lot of backup vendors are providing means to have immutable snapshots. There's no reason not to use these now. And of course, the reason that these are important is because these are read-only copies of your data. No one can tamper with them. No one can delete them because you set a retention period and they're kind of safe for that period of time. But just taking that snapshot doesn't really guarantee anything about it. Are you also making sure that you're checking that those backup targets are going to be clean to restore from as well? Because if you just get back more encrypted data, that's not very much use to you. So make sure you're using some other kind of software so that you can check the cleanliness of those backups. So once you're confident that you've got a fast and clean recovery point, that's great. You've got something to restore from. But if you really, really want to speed up your recovery, try and have the smallest amount of data possible that you need to recover. I mean, it makes sense, doesn't it? You know, it's going to take you a lot longer to recover petabytes of data than it is gigs or small numbers of terabytes. So it's just simple maths at this point. How can you minimize the quantity of data you need to recover? Just detect that something bad is happening as soon as possible. So in the flow of ransomware that we saw before, all of those kind of early warning protections had kind of failed at this point. Your data was being encrypted. Have you got the means that you can detect that that encryption is happening as soon as possible? And then secondly, just detecting it is not good enough. You've got to be able to do something afterwards. You're going to know what it is you're going to do. Are you able to automate some kind of recovery process? We know that with lots of regulations that are coming in at the moment, things like NIS2 in Europe or DORA for financial institutions, being able to test, time and test your recoverability is becoming more and more important these days. It's just becoming, part of regulations and compliance that you've got to meet. So that's the introduction. Now I'm going to talk to you a little bit about what we do with IBM Storage and with our FlashSystem product to help with that speedy recovery. So anyone here using FlashSystem today? I have spoken to a few people that have. Cool, excellent. very good people. Hopefully, you're using some of this stuff. There are some new things in here, so you might not be aware of all of these things. And for anyone that's new to FlashSystem, hopefully we'll be able to give you a little bit of an overview of some of these capabilities. So FlashSystem it's block storage, it's fast, performant, low latency, end-to-end NVMe, really geared towards mission-critical workloads, kind of all your online transaction processing, databases, stuff like that is what we're really, really good at. One of the big things we focus on is resilience. How can we protect that data? Because if storage can't keep your data available, it's not very good storage, is it? So that's one of the things that we focus on. We really view all of these resilience capabilities as being a kind of holistic set of capabilities that you've got. None of these individual technologies that I'm going to talk about are silver bullets. You've got to be layering on all of these capabilities if you want to get to resilience. So we have a number of capabilities to kind of secure access to the system, be able to recover data, and also integrate with other pieces of security software to help with that. And the two that I'm going to talk about today, I'll talk about this one first, so how easy it is to set up our immutable snapshots using FlashSystem and vCenter, and then secondly, some really cool stuff that we've been working on to do with ransomware threat detection that we've actually built into our hardware, which means it's very fast and doesn't impact your performance, so that's pretty cool. So let's talk about those immutable snapshots first. So thank you very much for the people that are using immutable snapshots right now. You're all very clever. I just want to show you how easy it can be to set up immutable snapshots, or just snapshots in general. This is basically a bit of me demoing and showcasing some of the integrations that we've got with VMware, but giving it a bit of a data resiliency kind of a spin on it. So what we're going to do, I'll just walk you through this workflow, show you how simple it is to get snapshots set up, immutable snapshots set up using FlashSystem. Firstly, we're going to set up a couple of things on the storage system that will take a few seconds. And then after we've set up that integration, you can do everything that you need to protect your data stores right from within vCenter. And obviously, this is such important stuff that we've now got the hissing in the background so that no one else can possibly find out about this stuff. So this is the FlashSystem interface from one of our recent versions. If you're using FlashSystem right now, hopefully this is familiar to you. And the way that we kind of enable the management of FlashSystem is kind of using these simple policies. So rather than you having to go and twiddle a load of knobs to set things up, the idea is you say, I want to set things up this way, create a policy for it, and then that policy will apply to all of the objects that you create afterwards. One of the types of policies you can create is a snapshot policy. This is pretty standard now across lots of backup software and across lots of storage software. How do we create a snapshot policy? Dead simple. We just give it a name, we say how often we want that to run, and we say how often do we want to keep that retained on the system. That's literally it. Just a couple of things to add there. We're going to create a volume group. So this is just a logical construct at the moment. Basically, here's your bucket from which you're going to be able to create volumes in the future. And then we're going to assign that policy that we just created, say when we're going to start taking snapshots, and just tick this little box here that says safeguarded. And that basically means these are safeguarded copies, which are these immutable snapshots. That's it. That's all the setup that needs to be done. Now we have this nice plugin for vCenter for IBM storage. This lets you manage all of your IBM Flash systems and also works with some of our other storage systems as well. You get a bit of an overview of what all your storage systems are, things like what the performance is, all of the code levels and important things like that. If you are using FlashSystem at the moment, this is all completely free. I would encourage you to download it and use it because it's really, really handy for lots of things. So if we've not done anything before with any of those storage systems, the first thing that we can do is create a data store. FlashSystem does support vVol as well, but this plugin is largely focused towards VMFS. So what we're going to do is create a data store, just say how big we want it to be, how many we want to create. We're going to select the storage system that we just set that policy up on. The plugin will go and evaluate all the host connections, make sure everything is connected okay, and then this is this policy that we just created, and we know that it's safeguarded, which means it's going to be creating these immutable snapshots automatically. Boom, click create, and it will set up all the objects on the storage system, it will map it to the host, it will check all the connectivity. That's it, you can just sit back and relax. So because we've got this group in here and it's got this policy that's automatically creating these snapshots, which we can view here, we can have a look within vCenter and we can see, okay, my next scheduled snapshot is going to be coming in, in however many hours time. And then boom, you wait until that time, all automatically gets created. So what we've been able to do within vCenter is click a few buttons, create a data store, and you know that that's automatically creating these immutable snapshots without you having to worry about anything else. This is a capability that's built in with the Flash system, but we do interoperate with other backup software as well, so various products from IBM, also things like Veeam, Commvault as well. We have those integrations with the snapshot capability. If you want to be able to restore from one of these after you've had an attack or for whatever reason, we've got a simple workflow that you can go through as well, where you just basically say, make me a new data store from that snapshot, show that we've recovered it, and boom, here we go. You've got your data store back, and you can start doing whatever you need to do to get those applications back up and running. So the idea is that this is hopefully super simple to set up, and if you haven't been using immutable snapshots in your data protection strategy so far, it's not anything that's complicated. It's something that's super easy to do, and like I said, if you're not doing it already, please do use that. Right. Second part here. This is the cool part that I was talking about. So, ransomware threat detection. So, as I mentioned before, sums. If you have got some malware that is infecting your system at the moment, I'm going to take an example. Lockbit 3.0, like any software vendor out there, the ransomware groups, they like to release new versions of their ransomware all the time. Lockbit 3.0 came out earlier this year, and one of the main capabilities of it is it goes really fast. That's bad news for everybody. So let's imagine that we've got some Lockbit 3.0 malware, it's been triggered, and it's attacking one system at 10 gigs a second. It's one of the more fast or speedier variants that we've got out there. If you didn't detect that for 24 hours, whoa, almost a petabyte of data is going to get encrypted. It's not a great thing for you to have to recover a whole petabyte of data. So what if we could find that problem a lot sooner? Okay, we've got a few 100 gigs to worry about. Not great. I mean, to be honest, if it was my data that was being compromised, I still wouldn't be massively happy if my bank details were in that 600 gigs. But in terms of recovery, way, 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 way less to worry about compared to almost a petabyte of data. So what can you do to try and detect data getting encrypted or attacked by malware that quickly? Let's think about a few different things you could do. And there's lots of technologies that are out there today, and you're never going to have just one technology that's going to solve this problem for you just because it's a complicated space. Let's think about some of the things that we've got available today. So there's lots of ransomware detection or malware detection software that kind of works at a file system level. These tend to be pretty thorough, comprehensive, go through a whole file system, have a look for signatures that, this binary looks like it might be malware, things like that. Snapshot scanning is quite common as well. If you think of the way that the ransomware detection in VMware Live Recovery works, rather than kind of working on the active data, every time you take a snapshot, they'll have a look at that snapshot and see if they can detect anything that's going on there. And that's great, but it can take a while because to go through a whole file system, it's going to take you, hours potentially to scan that. And it's performance intensive as well because of all of those kind of read operations that you're doing. What else can we do? So there's a lot of what I would call software-based anomaly detection. Having a look at data in flight to see if there's any patterns there that might be related with ransomware, things like changes in, compression ratios of data and things like that. These can work really well. They can work really well. But if you're doing something in software, it tends to be very compute intensive. If you're trying to run that all the time, you will tank your performance. So what you see most vendors do, whether they're running this software in storage or on the compute, is they're just sampling the data. They can't really have a look at every single I/O, which means you might not see all of the signals, and it might take a while for you to run that. So what we have worked on at IBM is to try and bring, in fact, we have brought the ransomware detection into the hardware. IBM, we benefit from the fact that we're a big company. We've got lots of different teams working on different areas, which means that we've got people that work in-house designing the hardware for us, and we also have a lot of research teams that are working on things like AI detection. We've brought all of those people together with our storage designers too, to come up with our FlashCore module, and I've got the guts of one of those FlashCore modules with me here too. This is basically a custom flash drive that we've designed ourselves. It's got a load of flash chips on it, but it's also got a processor. 2 of the 4 cores that run on this processor are having a look at all of the reads and writes that are going to the data and analyzing that for patterns and statistics associated with ransomware attacks. How do we know those patterns and those statistics? We ran the ransomware, and then we looked at what it looked like on the storage system. So we basically have trained the AI models that learn to look for this. So when you've got a flash system that's packed with these drives, everyone's got a processor on it, and you're offloading the ransomware detection basically to all of these devices that are in the storage. That means there's no performance impact to your application. You're not having to use any CPU cores on the compute to run all of this. It's all offloaded. What does that actually look like in reality? This one's an easily eyeballed example and just shows you some of the things that we've learned. So what we can see in this particular example here is in the periods where the ransomware is active, we can see, okay, we're seeing a high level of entropy. That's the randomness of the data compared to what happens in a normal workload. And we can see there's loads of write activities going on, whereas we weren't doing that in our normal course of action. This is an example of one of the patterns that we would look for to see if something looks like a ransomware attack. But there's 40 odd that we will look for. What we'll do is we'll have a look at a window of time. We'll check all of those 40 different statistics, and if it looks like all of them indicate that something looks like a ransomware attack, we'll throw an alert. So basically, all of these drives sit in the controller. The controller runs the storage virtualized software where we run an AI inferencing engine. That's basically checking a set of rules to say, does this look like a ransomware attack? If it does, we'll send out an alert. We've got this monitoring software called Storage Insights Pro. That will throw an alert, and then you can start taking that action. So you can get these responses hooked up to any kind of SIEM source software that you've got. We even are able to put these alerts into vCenter as well in the plugin that we've got. That means that you can take all the action that you need. You can start isolating devices. You can get an email sent out to your head of security and say, something bad is happening. You've got that automated workflow there. And also, we're actually recording what happens with all of these, which means that when we see people get hit by ransomware attacks or have a false positive, we can take that information and we can improve the AI model. I think I've just about got time to take you through a quick demo of what this looks like in practice. So this is the monitoring tool I mentioned, Storage Insights. We've got ransomware detection active on all of these systems. It's just defaulted on. You're not going to do anything to turn it on. It's all just automatically running in the hardware. You can configure these alerts to get sent to other applications. In this example, we're just putting in an email alert as well. And what we're going to do is simulate a ransomware attack. we've generated lots and lots and lots of different encrypted payloads, and we've got a custom tool that we've created. We call it WannaLaugh. It's kind of like the WannaCry ransomware, except we kind of created this fake version of it. So we've run that, sent it to the storage, and now, boom, we've got an alert that says this system has been affected, and it's potentially affected these specific volumes. We've made sure that these red boxes appear absolutely everywhere on the interface, so you can't possibly miss it. So we get information, we think that that volume has been affected. Let's have a look, see if we can get some more information about it. Okay, we think it's these volumes here, and we'll record when this happened as well. That's obviously very important for you to know when we detected this, because it gives you a starting point to understand, you know, where should you be looking, where should you be finding the right recovery point as well. When we drill down into one of these, which will happen anytime now, so if you've been taking immutable snapshots, we'll keep a record of all of those in Storage Insights, and any that have been taken since we saw that threat, they'll be marked compromised. That makes it very easy for you to eyeball, okay, I've got these snapshots here, those are probably the ones that I should start looking at as being my good recovery point. We've also tried to put interesting or useful information into the alerts as well. So when you drill down into any of these alerts, we'll show you information like this is the ESX host that it's affecting, and also here's like a recent history of what the performance of the system is, performance of the volume, things like that. So you can start correlating this with other performance information that you've got from across your infrastructure and start working out what's been affected. So that's just the quick demo of that. And as I mentioned, the latest version of the vSphere plugin that we've got, all of those alerts will also get piped in here as well. So if you're mostly focusing on vCenter, and that's a place where you have a look at everything, then you'll get notified from within vCenter as well, without having to kind of switch to all the different interfaces. And you can set up webhooks, push these alerts out to things like ServiceNow or Slack or PagerDuty, whatever it is you need to integrate it within your workflow. So thank you very much, everybody. If you want some help from IBM to kind of understand how well you are doing at the moment when it comes to being cyber resilient, we have a free cyber resiliency assessment that you can take. There's like a quick version you can do on the website, or you can sit down with someone for a couple of hours. It's really useful if you're kind of trying to get your bosses to take ransomware resiliency seriously. This will produce a report that you can show to people to say, this is where we're strong, but also this is where we're weak, and therefore maybe it will help you get some investment to kind of add in some more technologies that you need. And then if you want to talk some more with me, if you want to see what the FlashCore module looks like up close, I am at the IBM booth. It's number 10 or 11 in the corner upstairs. Feel free to email me, connect with me on LinkedIn, and I would love to keep talking with you.